We have given function. First, we will find the domain of this function. The domain will be all real numbers. Why? Because what we have here, we have multiplication. We can multiply by 2 every real number, and we have division. In the numerator, we have x squared plus 1 will never be 0. So the numerator is always different than 0. Why? Because we have x to second power. So we have always positive number here, or 0, plus 1 give us always positive number. So the domain will be all real numbers. Next, we have to find maximum minimum, so we need to find critical values. To find critical values, we need to find first derivative. We have derivative of quotient. To find derivative of quotient, we will use formula. Derivative of u over v is equal v times derivative of u minus u times derivative of v over v square. X squared plus 1 times derivative of 2x is 2 minus we have 2x times derivative of denominator is 2x. And we have x squared plus 1 to second power. This is equal. We can do multiplication. So we have 2x squared plus 2 minus 4x squared over x squared plus 1 to second power. This is equal negative 2x squared plus 2 over x squared plus 1 to second power. So we have the first derivative. Now we have to check when first derivative is equal 0. If and only if the numerator cannot be 0, so we compare only numerator. We have negative 2x squared plus 2 equals 0. So we can move 2 to the right side, so it will be negative 2x squared equals negative 2. Divide both sides by negative 2, so we have x squared equals 1. So x is equal 1 or x is equal negative 1. We have two critical values. Now to check if we have maximum or minimum, we will use the second derivative test. So we need first to find the second derivative. Y bis is equal. So it means we have to find the derivative of our first derivative. So again we will use this formula. So the numerator is to second power, so we will have x squared plus 1. We have to second power to second again, so it will be to 4 power. And in numerator, we will have x squared plus 1 to second power times derivative of our numerator, so will be negative 2 times x. A derivative of 2 is 0, so we don't have to write. Minus, and now we will copy numerator, so we have negative 2x squared plus 2 times, and derivative of denominator, we will have 2 times x squared plus 1. We copy whatever we have in parentheses to power 2 minus 1 times derivative of expression inside parentheses. So we have 2x. So this is equal. We have x squared plus 1 to second power times negative 4x minus, and we have 2 times 2 will be 4x I will put first this expression, so it will be x squared plus 1 to first power, and don't have to write, and we have times negative 2x squared plus 2. So over we have x squared plus 1 to power 4. Now we can factorize in numerator x squared plus 1. We have x squared plus 1. So we have x squared plus 1. We factorize. So in this expression we will still have x squared plus 1 because we have to second power this part, times negative 4x minus, and whatever left here we have 4x times negative 2x squared plus 2, close parenthesis, over x squared plus 1 to power 4. Now, because we have multiplication here, we can reduce this x squared plus 1. So we have in the numerator now x squared plus 1 to third power. So this is equal. We have to do multiplication. X squared times negative 4x. It will be negative 4x to third power. 1 times negative 4x is negative 4x. Negative 4x times negative 2x squared will be positive 8x to third. And we have negative 4x times 2 is negative 8x. And denominator we just copy. We have x squared plus 1 to third power. So this is equal. We can combine the like terms. So we have negative 4x to third plus 8x to third is 4x to third. Negative 4x and negative 8x is negative 12x over x squared plus 1 to third power. So we calculate the second derivative. Now to find minimum maximum, we will use the second derivative test. It means we have to calculate the value second derivative for our critical values. So first for x equals 1. So the second derivative for x equals 1 is equal. This is our second derivative formula. So it means we have to replace our x's by 1. So in numerator we have 4 times 1 to third power minus 12 times 1. In denominator we have 1 to second power plus 1 to third power. This is equal. It will be 4 minus 12 over 2 to third power. So 4 minus 12 is negative 8 over 8 is equal negative 1. Because the second derivative has negative value, it means for x equals 1 we will have maximum. To find the second coordinate, we have to replace x's by value 1. So y of 1 is equal, we have 2 times 1 over 1 to second power plus 1. This is equal 2 over 2 is equal 1. So we have our point. X is equal 1 and y is equal 1, 2. So this is our maximum. Because the second derivative has negative value for x equals 1. Now we have to check our second critical value. X equals negative 1. For x equals negative 1, the second derivative is equal. We will replace in our second derivative formula x's by negative 1. So this is equal 4 times negative 1 to third power minus 12 times negative 1 over negative 1 to second power plus 1 and everything to third power. So this is equal 4 times negative 1 will be negative 4. Negative times negative will be positive over will be 2 to third power is 8. So this is equal negative 4 plus 12 is 8 over 8 is 1. So we get positive value. It means for x equals negative 1, we will have minimum. We have to calculate the second coordinate. We have x equals negative 1. Now we have to replace in our formula, our function, x's by negative 1. So this is equal. This is our y function. So we have 2 times negative 1 over negative 1 to second power plus 1. This is equal negative 2 over 2 is equal negative 1. So we have our point. First coordinate is negative 1 and the second is negative 1, 2. This is our minimum. Now we have to check if our function has inflection points. To find inflection points, we have to set our second derivative to 0. So let me copy first our second derivative. We have 4x to third minus 12x over x squared plus 1 to third power. Okay, the second derivative we have to set equal 0. The second derivative is equal 0 if and only if we have to just copy our formula. We have 4x to third minus 12x over x squared plus 1 to third power. This must be equal 0. We have on the left side fraction. The denominator can never be 0, so we have to only compare numerator to 0. So we have 4x to third minus 12x is equal 0. We have to solve this equation. We can factorize 4x, so it will be 4x times x squared in parentheses minus 3. This is equal 0. We have multiplication on the left side. So when this left side will be 0? When 4x will be 0 or x squared minus 3 equals 0. So x equals 0 and we have quadratic equation. I will move negative 3 to the right side. So we have x squared equals 3. So x equals plus minus square root of 3. So we have 3 solutions. We have to check if the second derivative change sign a small distance to either side of our points. So we have 0, negative square root of 3 and positive square root of 3. The easiest way, in my opinion, is to draw the graph of our function 4x to third power minus 12x. So first we have to put on our number line x our 3 values. We have square root, negative square root of 3, we have 0 and positive square root of 3. This is negative. So we have to check first our coefficient before the highest power. X to third has positive value. It means we will start to draw the graph from positive values. Above x-axis we have positive values and every root fits 1 times. So we just pass this point and we see for square root of 3 we change the sign from positive to negative. So everything is okay. At 0, we change sign from negative to positive because this part of our graph is above x-axis, so has positive values. This is under x-axis, so has negative value. And for negative square root of 3, this part of our graph is above x-axis, so has positive values, and this part is under, so has negative values. So we have 3 inflection points. To find the second coordinate, we have to calculate value for our function for this 3 axes. So first, for x equals negative square root of 3, we have to replace in our formula y function x's by negative square root of 3. So we will have y of negative square root of 3 is equal 2 times negative square root of 3 over, we have negative square root of 3 to second power plus 1. So this is equal negative 2 square root of 3 over negative square root of 3 to second power is 3 plus 1 is 4. So this is equal 2 and 4 we can reduce. So we have negative square root of 3 over 2. So we have first inflection point. The first coordinate is negative square root of 3 and the second coordinate is negative square root of 3 over 2. Now we have to calculate this point, the second inflection point, for x equal 0. So for x equals 0, we have to replace in our formula of our function x's by 0. So this is equal 2 times 0 over 0 to second power plus 1. This is equal 0 over 1, so this is 0. We have second inflection point 0, 0, and the third is for square root of 3. X is equal square root of 3. So y of square root of 3 is equal 2 times square root of 3 over square root of 3 to second power plus 1. This is equal 2 square root of 3 over 3 plus 1. So this is equal 2 square root of 3 over 4. 2 and 4 we can reduce, so we have square root of 3 over 2. The third inflection point has coordinates square root of 3 and square root of 3 over 2. This is my solution.